Hello, so we've got quite a long problem here with a long solution. So let's get started. All right, so pentane and hexane form an ideal solution. At 25 degrees Celsius, the vapor pressure of pure pentane and pure hexane are 622 torr and 160 torr, respectively. What is the vapor pressure of the resulting solution made by mixing 35 mils of pentane with a certain density with 55 mils of hexane with its density? Hint, use the two-component formula of Raoult's law, since both components of the solution are volatile, and each will contribute to the vapor above the solution. Okay, so we've got a few steps that we're going to use in order to do this. First things first, I notice that I'm going to go through and I'm going to read and list what they've given us. So we've got pentane and we've got hexane. And for pentane, they told us 622 torr was the pressure. So that was the initial pressure of, I'm going to call this P. Like right here, instead of A, I'm calling it P for pentane, and then instead of B, I'll call it H for hexane. So then we've got our starting pressure of hexane, and that one was 160 torr. All right. So then they give us the volume of each of those. So volume of pentane, volume of hexane, and for pentane it was 35 mils. And for hexane it was 55 mils. And then they tell us the density of each one. So the density of pentane, the density of hexane. For density of pentane, it was 0.63 grams per mil. And then for hexane, it was 0.66 grams per mil. All right, and then they tell us this to use, but we're going to have to do a few things before we get there. So first things first, I'm looking at this and I see the mole fraction. And I think to myself, well, I can get mass from density and volume. So density equals mass over volume. If I multiply both sides by volume, then that gives me volume times density equals mass. So the mass of pentane will equal the density of pentane times the volume of pentane, and the mass of hexane equals the density of hexane times the volume of hexane. So I'm going to put those things here and multiply 0.63 grams per milliliter times 35 milliliters. And then for this one, 0.66 grams per milliliter times 55 milliliters. So let's see, I did this on a different sheet of paper. I did the math and I had to go get that. But I changed the numbers. So I'm going to stick this in the calculator real quick, hopefully real quick. So I've got 0.63 times 35, and I get 22.05. My mils in the denominator cancel with mils in the numerator, and that leaves me with grams. And then for hexane, I have 0.66 times 55. For that one, I get 36.3 grams. Again, the mils cancel. Okay, so now I've got mass in grams. I need to convert that to moles. So I'm going to have 22.05 5 grams of pentane. And I'm going to multiply that by a fraction here. If I've got grams of pentane here, I'm going to have grams of pentane here, and then I'm going to have moles of pentane here. I'm going to do the same sort of thing on this side. 36.3 grams of hexane. And then down here I'll have grams of hexane, and I'll have moles of hexane. Now I need to find the molar masses here. So they told us pentane C5H12. So down here, C5H12. And then for hexane, it was C6H14. So here, C6H14. All right, so I've got carbon, I've got hydrogen. I've got 5 carbons, 12 hydrogens. If I look on my periodic table, for carbon, the atomic mass is 12.011, and for hydrogen, it's 1.00794. And then for hexane here, I've got carbon, I've got hydrogen. I've got 6 carbon, I've got 14 hydrogen. And then my atomic mass for carbon and my atomic mass for hydrogen. So we're going to multiply, multiply, and then add. Same here. We're going to multiply, multiply, and then add. So 5 times 12.011. That's 60.055. And then 12 times 1 point. And in a few seconds, my camera on my phone's going to run out. So this is going to be part 1, and I'm going to finish it up in the next part. So I will see you in the next part.